Hi everyone, thanks for clicking onto the video. We're just looking at a bit of recap into calculating inductance and capacitance. Obviously we're looking at an AC circuit, so we're going to combine inductance, capacitance, maybe some resistance, looking at getting impedance and current flow. So a few different examples I'm going to work through on the screen. Hopefully you'll be able to pick up this pretty quick. Got the calculator on the screen as well, so you can see exactly what I'm typing in to get the answers that we're looking for. So the first question that you're looking at, it says you've got 0.25 Henry's inductor. Remember, Henry's is inductance, with a 35 ohm resistor. And it's connected with a capacitor of 42 and a little symbol there with farads next to it. And the little symbol there means micro. So micro is times 10 to the minus 6 times 10 to the minus 6. As you looked on there. On the calculator on the right hand side, we use the EXP button at the bottom. So EXP, the minus that's in brackets on the left hand side, and then 6. And it converts our number down. But we'll look at that in a little bit more detail once we get going. Okay. So the final bit of the question actually asks us to work out current. But as you all know, it's not a straightforward process. So we're going to build this up. So the first thing I'm going to do, guys, is work out inductive reactance. So inductive reactance is XL. So XL, and we work that out by doing 2 times pi times frequency times inductance. So XL equals 2 pi FL. So we should have all the information in the question when we're trying to work this out. So 2 times pi, which is 3.14. You can click the pi button on the calculator as well. Times by frequency, which shown in the question. I'll highlight that in pink, and it's 50 hertz. So 50 hertz is your frequency there. So times that by 50, and times that by inductance, which remember is measured in Henry, so 0.25. Nothing we need to do with that. Sometimes you get one that says millihenries. Then we obviously have to do times 10 to the minus 3, but for this we don't have to. So on the calculator on the right hand side, I'm just going to type that in. So 2 times pi, which is at the bottom. If I press the shift key and the EXP, you can see the little pi symbol. So 2 times pi, so it's updating the calculator already. Times by 50, my frequency, times by 0.25, hit the equals button, and it gives me an XL, which is inductive reactance, of 78.5. And the unit of measurement for reactance, no matter what type it is ohms. So 78.5 ohms. So nice straightforward step 1. Step 2 that we're going to look at is measuring our capacitance. So capacitance is slightly different. It's X for reactance and C for capacitance. So capacitive reactance XC. And the equation for that is 1 divided by 2 pi F for frequency and C for capacitance. Nice and straightforward. I'm just going to create a bit more space on the screen here, guys. So give me 1 second while we move all this out of the way. Write that down there out of the way, a little bit out of the way. Yeah, a little bit of space, but hopefully we may come back to that question a little bit. Okay, so XC is 1 over, so 1 is constant. We know number 1 is never going to change. It's what we've been given. 2 times pi, which 3.14 again, times by frequency, which is still 50. It's the same question. Times by capacitance, which has been given to us as 42. Remember the symbol I said there? Microfarads. So 42 microfarads. So 42 microfarads, which is times 10 to the minus 6 on a calculator. So XC equals. If you have a look at the calculator on the right, guys. So what I'm going to do to start with, use my fraction button This makes sure I can't make any mistakes, because the one thing people do when we're doing these calculations is they don't put brackets around. But by using this, you don't need to use brackets. It does it all for you. So 1 on the top, the bottom, 2 times pi times 50 times by 42 exp, which is your times 10 button at the bottom, to the minus it's in the brackets there, 6. And it's giving us 75.78. And again, we're measuring that in ohms. So we've got an XL, which is 78.5, and XC, which is 75.78. So the next stage we're looking at is working out X. So X is a difference between XL and XC. It doesn't matter which one's bigger, which one's smaller. It's just a difference. So the biggest take away the smallest. So in this case, it's XL to biggest minus XC. So what we'll do there, we'll do 78.5 minus 75.78. So on my calculator, we'll do that. 78.5 minus 75.78. It gives me an answer of 2.72. 2.72 ohms. 2.72 ohms. So that is X. So looking back at the question, we're going for the current. So to get current, the equation that we're going to use is our VI R triangle, when we consider that, going back to your level 2 days. We're going to replace that, and what we're going to do, we're going to replace the R with a Z. So I'll delete the R, and now this is an AC, Ohm's law. So V equals I times Z. We're working out I, so I equals V over Z. So as you can see from what we've got so far, we've got an X, we haven't got a Z, so we need to calculate what Z is. So I'll move across over this side. So let's change the pen so we can track this. So Z equals the square root of R squared plus X squared. So nice straightforward, Pythagoras. So everyone's familiar with Pythagoras. So R is what we're looking for. So we look back to the question, resistance, which is your R, is giving us 35 ohms. So let's highlight that up a bit. So 35 ohms. So square root of 35 squared plus X squared. So X we worked out as 2.72. 2.72 squared. So we'll put that in the calculator. So the square root symbol in the middle there. 35 squared plus 2.72 squared. So the key thing to this, guys, make sure it all falls underneath the square root and we're not square rooting part of it. And you see the answer is just slightly above 35. When you're doing this in an exam, guys, make sure that you put the 0.1 part. Otherwise, anyone looking at this question will just think they've just used the 35. They haven't bothered working out the reactance. They've just used the resistance. And we haven't. We've done a lot of work. So we'll show that step by step. But 35.1 just shows a clear understanding of what you're actually working out. So my Z is 35.1. So back to my equation over here. I equals V over Z. I equals V over Z. So voltage given in the question, where are we? 230 standard AC. So 230 divided by 35.1. So we'll do it on the calculator. 230 divided by 35.1. And it gives us a current of 6.55. So we round it up, can't we? Round it up to 6.6 amps. 6.6 amps. Okay. So 6.6 amps. that is our current. A bit bigger. The best of colours to use there. So we'll put it back to the red. 6.6 amps. Highlight that yellow. Should stand out there. So 6.6 amps. That's what was asked in the question. It said calculate the current. The current is 6.6 amps. And you can see from the question, that's 5 marks. That's 5 easy marks just by doing this step by step. You've got to show you're working out as you go along, because that's where you're getting your marks from. However, the good thing with this question, if we make a mistake, so if we made a mistake over here on the XC, we got the XC wrong, we'd only lose 1 mark as long as we carried on our wrong answer. They totally accept that. They understand you can make a mistake, and by flowing it down, they allow us to get the 4 marks still. Even though we've got 1 bit wrong, we can still get 4 marks. So it's good. Even if you're unsure a little bit, give it your best go, and you're always going to get a couple of marks, hopefully. So that there is how we work out current when we started with resistance, capacitance, and inductance. So nice, straightforward. Hopefully that helped you a little bit working out this question, guys. Thank you.